Okay, let's continue our study of the similar solids. Now, we did perimeter, we did area. Now, let's say we take these two squares here. Let's turn them into cubes. So if we turn them into cubes, they're going to look like this. Let's just, you know, look like this. So we have cubes here. So what would be the volume of this cube? So if this cube here is 16 by 16 by 16, the volume of this cube is going to be 16 times 16 times 16 centimeters. It'll be 4,096 centimeters cubed. Okay, so what would be the volume of this one? So again, it was 4 times longer, right? 4 and 16, we made it 4 times the side length, 4 times longer. Now what's going to happen to the volume? Well, 4 times 4 times 4, that's the volume. That's going to give you 64 centimeters cubed. Now let's take the ratio of volumes and see what we get. So the ratio of volumes will be the big one over the small one again, keep the same thing. 4,096 over 64, and that's 64. So the ratio of volumes is 64. Let's just review everything now. So we have 3 different ratios. And this one's going to be called, this one will be called a 3D ratio. 3D ratio, because we're comparing cubic, we're comparing cubic units, we're comparing volumes. That's 3 dimensions, length, width, and height. And let's just review everything. And these are the 3 ratios that we have. We have the 1D ratio, which was 4. So the side length was 4 times bigger. The 2D ratio was 16. If we compared the 2 areas, we have this area and this area. This is 16 times bigger. The area of this face is 16 times bigger than the area of this face. And the volume, what we just saw, is 64 times bigger. So by multiplying the side length by 4, we 16 times bigger the volume of the area and 64 times the volume. So here we have a summary, 1D, 2D, 3D ratio. How do we go from one to the other? So how do we go from 4 to 16? Well, because we had length times the width, or side times side, we multiply it each side by 4. So that's squaring it. We're going to square it. So in order to go from here to here, we have to square it. Oops. This is what I wanted to do. I'm going to square it. So from the 1D ratio to the 2D ratio, 4 times 4, 16. And how do we go backwards? Well, what's the opposite of squaring? It's square root. Square root of 16 is 4. That's how we go from the 2D ratio to the 1D ratio. How do we go from the 1D ratio to the 3D ratio? Well, 4 times 4 times 4. Cube it. You get a cubic. And similarly, how do you go back? You have to cube root it. The cube root of 64 is 4. The square root of 16 is 4. If you have the 1D, square it, cube it. And we could also write it like this. So the 1D ratio would be, in this case, it was 16 over 4, which is 4. Or 16 over 4 squared is 16. And 4 cubed is 64. It's another way of looking at it. So now when we work on problems and we're comparing different lengths or areas or volumes, we have to use the correct ratio. So if we're comparing areas, we have to use the 2D ratio. If we're comparing perimeters or lengths or heights, we have to use the 1D ratio. If we're comparing volumes, we have to use the 3D ratio. And that is what we're going to see in the next video.